Jai Hind students, I Ayushi Gupta from Department of Computer Science and Engineering welcome you all to the digital lecture series of Programming for Problem Solving. So today we have our first lecture and I will cover the topic that forms the unit 4 part 2. That is one of the topic of very important topics, structure, union and enumerated data types of C programming language, and we are going to cover the structures topic in this lecture. So first of all, let me introduce the structure concept. What do you understand by the structure? What are structures in C programming language? So structures can be defined as a user defined data type that shows multiple values of different type under a single unit. Okay. Previous two structures you have seen one of the data type, that is arrays, and arrays we very well know that arrays store all the data types, but that needs to be of single type only. If you are storing numbers, only number either of integer type only or float type only one you can store, or characters if you want, that only one type of data type, that is either character either or integer or float, and one time you can store only one single data type in an array. But our requirements are not so. We need to store multiple data types in under one single unit, sometimes to refer to them as a whole. So structures will allow us to do that. So it is defined as the user defined data type that will be storing multiple values of different data type under a one single unit. So here are some of the important highlights of the structure that we need to take care and we will be using to create structures in our program. So as similar to array, all the elements of a structure will be stored in sequence in memory. They are addressed in a sequence like we used to do in array. And every element, every data type that you will be storing in a structure will be known as member. Every data type of an array structure will be known as member, and each element may or may not be. Basically you will be using different only, but it there is no such restriction in structure. Basically it is used for different data types, but if all are same, all that is also no problem. So of same data type you will be storing each element or different type. You will be using the keyword struct. The struct keyword will be used to create the structure. So let's have a look at the basic example of how you can create a structure. Structure will be defined as per the following syntax. We will use the keyword struct. Then after the struct keyword, you will take any name that you want to assign to the structure, as you used to do in the case of array. Any array name you want to assign, you can do. Likewise in structure also you can take also a user defined name, and but you have to use a keyword struct before that. So struct and structure name, and then for this compound unit, this curly braces are used. Okay, when you start the structure, define it and you start the curly braces, and any number of data types, any number of members you want to be in that structure, you can list them out and separate them with the help of semicolon. Members inside this structure will be declared as any normal data member that you declare with their data type before, what the data type of that member, and their name. Fine. Then if you have more than one data type, more than one members, you will separate it with the help of semicolon till you reach the end of the member, and then end the curly braces, and at the last, after the curly braces, to mark the end of one single type of structure, please use this semicolon. So this is how you can define a structure. So let's have a look how structure takes memory in the system. We have one example of one structure. Let's say struct my struct. Okay, I have taken one sample structure, that is the name my struct, and it is of structure type, so struct keyword is used, and three members I have taken here of different types. One is integer, character and float. So variable 1 is of integer type, variable 2 is of character array. So it has within it 8 members. Okay, like you declare an array. Third member is float type variable 3. Then ending this struct my struct, and this is the variable, this is the object of my struct that I will discuss later. And if you can skip this, then this semicolon to mark the end of the structure that you have declared. So in the memory, how this structure is taking space, how it is organized. So the structure takes the whole space as many members have it inside it, and as per the data type of those members that you have specified. So for example, let's starting, because it is sequential in memory assignment. So let's say first is variable 1. Okay, so variable 1 is of integer type, and integer is taking 2 or 4 bytes. So 4 bytes are assigned here for integer. Variable 1, 4 bytes are assigned here. Okay, since only one variable integer, so it is 4 bytes are for this single variable 1. Then after this in the sequence we have variable 2. Variable 2 which is of character array type. So character, we all know that character takes one single byte, and in this character array we are having 8 elements. So 8 blocks will be associated with this variable 2. So 8 memory blocks are assigned. This variable 2 is occupying 8 blocks. Fine. Then we have variable 3. Variable 3 is of float type, and float takes 4 bytes in the memory. So these 4 bytes for variable 3. So this is how you can imagine and how memory is organized in the case of structure. As many members you are having, what are the data types of those members, as per that specification memory will be assigned to the structure. So the total size of structure will be the total amount taken by its members. So the importance of structure that I will like to discuss is, of course, because in the case of array there is applications are restricted, like you are want to make one single unit, want to refer to various elements by one single unit, that you can do, but the only restriction is you have to use a single data type only. Okay, but let's say if you are making some applications like book management system or a class management system that has members of various different types. In books you have various entities, like you have cost of book maybe in float, page number in or the book number in integers, or the book title in characters. Fine. And then if we talk about student management system, also student management system has various detail of students like roll number, name, marks, that are in of different data types. So if we will be creating different arrays for those entities, that will be very difficult and would be very large to handle. So if we can have a single unit under which we can assign various different data types of different data types under one single unit, that will be very efficient, very fast, and will take smaller space also. So let us discuss some examples of the different structures that we can have as per some of the applications that we have discussed. So for example, let me give an example of declaring a structure student. Okay, if there is a student entity, what different data types you can associate with that. Okay, so let's say here rn specify, of course the student has various features, like it will be he or she will be having the roll number. So roll number, for roll number we can take one variable rn, and rn we have taken off integer type. Then the marks percentage of the students will be in float, so I have taken one member as float per, that will specify the same. And for the name, of course the name of the student, I have taken one character array of any idea, let's say 20 size, so it will be for the character names of the student. So all these all these units, all these entities, all these features I can take one under one single unit, that is one structure. So for declaring this as structure, I combine in one multiple braces block, sorry, curly braces block, because it is a structure, so I have taken the word struct here, and the structure name I can assign myself, so I have taken it is referring to student, so I have taken the structure struct student. Any name that is close to the entity you can take. The second similar example is of employee. Let's consider an employee entity. So employee in an organization will be having details such as he will or she will be having their IDs. Employee ID is created. They will be having a name and for their salary and other details also, but I have considered only these three. So ID will be of type, let's say, integer, and the name will be a character array, and salary, let's say, in float or any data type, suitable data type you can take. So this structure also you can create as per the syntax of structure, and I have named it as employee, struct employee. Some more examples of these structures are, as many structures you want to declare, you can create by deciding the number of members that you have to take, the entity for which you have to make the structure, that depends on your requirement, that depends on your application. So if we have, say, structure date, so date has date has entities like it has day, month and year. So all these are of integer type. I have created one structure date to signify that. Struct complex is showing the complex number. Complex number has entities like real part of a number and imaginary part of number specified by iota. So for that you can also create a structure. These are some details, book structure also. So as I discussed previously, that book is having details like account number, its title, author, how many copies are there available in the library of that particular book. All these can be associated with the data type and listed in a structure. So students, let us take a look at how we can create variables of a structure. Okay. So what, let me clarify the meaning of why we creating the variables of this structure. Okay. So let's say we have one data type integer. When we declare the data type in a program, and let's say various variables of integer data type that we have to use, we declare as in the beforehand only, like integer a, b, c, d and so on, as many integer type of these variables that you want to use in your program. So if you have created structure an entity is there, so how many units of that particular entity are there in a program that are to be used? For that we create variables of the structure. So it will be clarified with this example. Let's try to understand this. So let's say if you have structure employee with its ID, name and salary that you have defined as follows, then employee is one single unit, employee is one common entity. But in your organization, we have more than one employee, two employee or more than that. Okay, n employees can be there. All will be sharing all these same features only. Yes, if a particular person is an employee, the features that are associated with that employee are also applicable to other employees as well. Others will also be having some ID, name and salary. But for the value of these members will differ for every other employee. Like my name is different from other employee that we have in a same organization. Our salary may be different, our ID is unique. Every employee is having different IDs. So if you are making a system, if you are making a program on that particular application, so you need to create variables for that, so that you can associate different values of these members that you have taken in your structure. So if when you have declared a structure, when you have declared the structure, after declaring the structure, the different employees can be referred as, like you have struct employee, then once struct employee is created, as many employees that you want to refer, from this single unit is you can list here. Okay, like for now I have I want to consider only 2 employees, and of course they will be sharing these common properties only. So I have referred to them as struct employee E1 and E2. Employee E1 and E2 are the employees, are the variables of this structure variable. The list can be endless. You want to add and as many employees as you want. So this way you can create the variables of any structure that you want. So this was one of the way. Other way possible is, second method of doing the same is, after declaring the structures, so you can write the structure variables this way also. After ending the structure declaration, before the semicolon, you can list the employee variables here. The other way is, first declaring the structure, first defining the structure, the variables that you want to take and the value that you want to give to them. For example, we have created the struct book structure, and let's say I have taken variable as B1 and B2. Two structure variables of book I have taken, and they will be having the same features, name, price and pages, but their value will be different. So for book 1 B1, I want the name to be as basic, right? The second entity, that is price, it is showing the price, and the pages it is showing as 550. So these three in the order are showing the particular values of these members that I have taken in the structure book. Structure book B2 is having the name as physics. 150.8 is the price of this book and 800 are the pages. So these are the specific value of these book variables B1 and B2. Any approach of creating structure variables that you want to use, you can use. There is no hard and fast and rule in that. So let us consider one simple example of first example of how you can print the output, how you can print the how you can create and print the output of any structure program in C. So first of all, after declaration of header files, the first is to what structure that you want to use, you have to declare is that, like you used to do in the case of variable declaration. So I want to use here the employee structure. So I have created one struct employee. Employee is having the following properties, like I have taken ID of employee as integer and the name of employee as character. One employee variable I have taken as E1. Then no other requirements I need to do here for now, and I have started the main function. So now assigning, after declaring all the members and the name of the structure, I am starting to assign the value of this structure employee. So for employee 1, I want to set the ID as 101. So the way of writing this as E1 and which member you want to access. The structure member that I want to access is ID. So E1 and ID, and for E1 ID relation I use the dot operator. Okay, E1 dot ID will refer to the ID of employee 1, and the value that you will be assigning is that depends on what value you want. I have taken as here 101. So with this step, I have set the ID value as 101 that will be stored in the memory. Now the second member is name of the employee. For this, we cannot do this directly by using the dot operator. For this, we in C programming we will be using the function strcpy. We will be using the function of string.h header file that I have declared here, and it gives the function strcpy by using which I will be assigning the name of employee. So for strcpy, what name you want, that will be the second point. That I want, like I want the name Ram for this employee 1. So this is the second member, and in which you want to give the name is employee 1 dot name, like in the case of id. But here we didn't use any string copy function, because obviously it is not a string, and for name or any strings we will be doing this strcpy only. So employee 1 dot name will point to Ram. That name is assigned to this employee 1. Then for after inputting the values of this entities, these members, we want to print this. So to print this on the screen, we have used the printf function, because we are doing C programming language. So first I want to print the employee ID. So printf function, and I have taken the message as employee 1 ID, and employee 1 ID is stored at what value? Even what variable? Even dot ID, right? Like the normal variable we used to do printing. Because it was of an integer type, so we have taken %d format specifier. So it will print the ID as 101 on the screen, and for the employee name printing, the message goes like employee 1 name. Because it is of string type, character type, the format specifier will be %s, and the storage is in even dot name. So let us check the output here. So of course the ID was 101 and the name was Ram, that is printed on the screen. So this is how you can use the structures to create user defined data types that refers to the one or more data type of same or different data type. So students, after one basic example of structures, how you can create a structure in C program, we will have the practical example of the practically used example of structures, that is array of structures. Okay, so as in the previous example that you have seen, like let me show the screen. If after creating the structure employee, I am how many employee I want, like we are creating variables here. For example, E1 and E2, and in this example I took only E1, so that is showing the only one employee of that organization. But the practically what happens is more than one variables are there for a program that you want to make is for more than one variables. Student number is also large, employee in an organization is also at least 10 or 20, 15. So if we want to create variables for those structures, we will be writing different variables manually. Like we will be creating, if 100 variables are there, we will be writing all the 100 variables of that structure. So that is very time taking and not efficient also. So what we do is we create array of these structures. Okay, so let me show you how this array of structure is created and what is the importance of that. So let us consider one example. I have taken one structure employee. Employee is having the members as ID, name and salary. After creating the employee, I want to refer the variables of this structure array as I want two employees. Okay, so in by the previous example I would be writing E1, E2 or so. Okay, but now I can create the array of as many employees as I want. For this, what we'll be doing is, one way of writing this is the employee structure that you have taken, again refer to this as struct employee, and only one single variable to take. Now instead of taking multiple, variables of that structure, only take one single name. And how many employees that you can refer to as, that you can create as an array. So if I have wrote it like this, EMP square bracket and any n number can be there. So this is showing me that 2 employees are there. Okay. So this has created 2 employees. All are accessing these members of this structure because they are a part of structure employee. So now what will be the size of this structure? Of course, as we have previously discussed, that any size of the structure is of data type of each of its members, how many space they are taking. So size of one single employee is integer of 4 bytes, character array 5 bytes, and float salary we have taken 4. So 5 plus 8 will be 13. This is only for single. But because we are having 2 employees, then the total structure size will be 2 times of this 13 bytes, that is 26 bytes. So these are created in memory like this. So let me show you with the help of program how this array of structures is created, and that is very also important from exam point of view. So let's say we have taken one structure student. Okay, we have taken a structure student and we have taken the members as ID, name and percentage. Right now we have declared only one single structure, one common structure student, and in the main function I want to maintain the record for 3 students. So instead of writing 3 variables, 3 structure variables of the type student, I will be creating the array of structures. So that's why I have declared as struct student record, and inside that 3 number, because I want that 3 students record to be maintained in this program. Now for assigning the values to these structure variables, for obviously for every student there will be different value of ID, name and percentage. So for first student, as we already know the array concept, how indexing is done. So using that only, for first student 3 students will be referred by the indexes 0, 1 and 2. Fine. You can start from 1 also, but by default we starting from the 0. So first student, second and third student. So for first student, the we want to set the first member, that is ID. We have taken the variable name as record. So record 0 indexing is referred to the first student, and we have taken the member as ID. We want to set the value of ID for this student. So ID that we want for this student is 1. And the name of the student, as I mentioned before, that we will be using the strcpy function for this. So we want to declare the name of this student 1, and so we have used this strcpy function. So I want to write the name for this student as Ram. So using the same format of strcpy, we have written like this. Now the percentage of student will be, because it is in the variable percentage as declared in the structure. So record 0 refers to the first student's percentage, which I have taken to be as 86.5. So with this I am done with the first student's record declaration. Now for the second student, we will be taking the ID as, so second student referred by the ID 1, index 1. So record 1 dot ID is equal to 2. With this I have set the second student's ID as 2 and the name as Ria, and the percentage is 90.5. Okay, so then third student's record is record, third student's record will be indexing. At indexing 2, its ID will be 3 and name I want as Shiv and percentage as 81.5. So students, with this we have set the values of every member for different students that we have taken as, and I have taken 3 students, so I have maintained the records of 3 students here. Fine. Now for printing these details we will be using the printf function. Okay students, with this was all in the C structure program. Thank you all. Thank you so much.